In this last video, we're going to begin to talk about describing a distribution for quantitative data. So when we're describing a distribution, we want to talk about the shape, the center, and the spread of that distribution. We're going to talk about the center and the spread in Chapter 3. So this is all going to come in Chapter 3. In Chapter 2 here, we're going to discuss the shape. When we talk about the shape of a distribution, there's always three things we want to talk about. We want to talk about whether or not the distribution is skewed or symmetric. We want to talk about the modes of the distribution, meaning the number of humps. And then we want to talk about any unusual features, and this, for the most part, is going to equal outliers. So let's start with the first thing, the difference between symmetry and skew. So symmetry means that you're going to have the same mirrored image on the right half as the left half of a histogram. But please be very careful. When you were taking an algebra-based course, symmetry was perfect. In statistics, nothing is ever perfect. You're never going to see a perfectly symmetric histogram. So we always talk about something being roughly symmetric or close to symmetric. So this display right here is pretty close to symmetric. If, however, you see that there's kind of a tail going off, so right here, there's a tail here and there's a tail here. These would be skewed. And when we talk about the skew, they are skewed in the direction of the tail. A lot of people mix these up. So right here, you can see the tail is going towards the right. So we would say that this is skewed to the right. Whereas here, the tail is going to the left, so this is skewed left. It's really important to be able to distinguish whether or not a distribution is symmetric or skewed. We also want to talk about the modes of a distribution, meaning the humps that you see in a histogram. So this first one is unimodal, because for the most part, there's just kind of one general hump. I always think, like, if you squint your eyes really hard, how many of these humps are you going to see? So we have unimodal, bimodal, and then this last one is multimodal, and I don't even know if I can draw it here, but you can see that there's a lot of humps going up. Uniform means that it's basically the same all the way across. And again, I'm going to go back to that idea of nothing's perfect in statistics. So it's going to be very rare that you see every bar straight across. But you can see that with this distribution, it's pretty close to uniform. The last aspect of shape is to talk about the outliers, or any unusual features. An outlier is a data value that is far above or far below the other data values. It could be that there's just an error in the data collection, or it could be that that outlier is a really important value. So, for example, say that you're collecting data on heights of college students and somebody puts down 3. You know that that's going to be some kind of error, right? That doesn't make any sense. But say, on the other hand, we were talking about income and Jeff Bezos was part of the data set. Well, he's going to be an outlier, but it's not a mistake. So some outliers are mistakes and some aren't. They're important to be able to differentiate between the two. An empty bin does not always indicate that what comes right after is an outlier. And I know I said that just a little bit ago. And then finally, again, we're going to talk about how to actually calculate outliers in Chapter 3.